Hello, I'm Jesse with American Radon Mitigation. We're just finishing up an install for this family. This house was built in 1978. I had a radon level of 15.7. Let's go ahead and take a look and see what's involved. So down in the basement, we've got the front of the house to my left. We've got the bathroom there. We've got a bedroom and another bedroom. And then behind Chris, we've got the living room here. So this is the front corner of the house, and then the garage is directly behind me. And then over here, we've got the mechanical room. So now we're in the mechanical room. We've got the garage on the other side of this wall. This is the back of the house. And we've got the bathroom right behind me here. So the first thing we do when we are installing a system is we want to drill our diagnostic test holes. So this allows us to measure pressure field extension, or how far our radon system is reaching. So to do that, we drill a 1/2-inch hole through the concrete in different areas of the home. We seal a rubber stopper in the floor like this, and it's hooked up to this tubing. So we've got them, 8 of them in this house, and we want to find our furthest, weakest test hole or location of the home. So our tubing all comes back to our micromanometers here, and this allows us to measure the suction or the negative pressure under the home. The key to getting your levels low is to get suction or vacuum under the entire house. So this allows us to design and engineer a system capable of doing that. So after we get our test holes done, the next step is to find where we want our first suction point. So I've done diagnostic testing to determine which area gives me the best pressure field extension. So our first choice was here. We chose this spot because we're next to the footing and we're next to plumbing. So we get into some looser soils that allow for better pressure field extension, because the radon system is able to pull air through that loose soil better than a compacted soil. So I've got a 10-gallon suction point. There was 4 inches of sand and gravel. And then it was clay below that. So after I got my suction point done, I sealed this pitot tube in the floor, and this allows us to use our shop vac to mimic a radon system. So I hook the shop vac up here with this valve. I can choke it down to more mimic a radon fan, and I can measure how much air I'm moving through that, so I'm able to simulate that radon fan. When doing that, I found that I wasn't reaching the far side of the house where the bedrooms are. We weren't making those test holes negative, and then the same up by the TV in the front corner. So we needed to add a second suction point. So if we come over here, now this house doesn't have drain tile again, so we want to be next to plumbing. This gets us closer to those bedrooms, and the bathroom's right behind me here. So we've got a 15-gallon suction point here. A thing to watch out for when you're next to a shower, this is just a fiberglass shower pan, is a lot of times there's a plumbing block out to a hole about that big where there's no concrete, it's just open to the soil. So here the shower pan sits on the floor, we can't seal that hole, so we end up foaming the shower pan to the floor. And this works really well for that because we can shove it in there and get all 4 sides. Another thing to mention here is also when we applied suction here, the bathroom, or the toilet, which is just a few feet away, there's a big air leak there, so I had to silicone around that toilet and seal it to the floor. But this suction point allows us to reach those bedrooms. But after that, we still weren't reaching up by the TV, so we added a 3rd suction point for that. So we'll take a look at that. So here, you may think, well, you're not in the living room. We're not. So what we've done is added this suction point. We dug a suction pit here as well. We did 15 gallons. And this is a load-bearing wall. We don't have a beam running across the house. So that means there's a footing under this. So there's a center footing that runs from the garage all the way to those bedrooms, which makes it really hard to get airflow on the other side of that, especially when it's sitting on clay. So what we've done is stitched under this footing. So a suction point, and then I augered down under the footing, and we'll go to the living room on the other side to show you the rest of it. So here we're in the living room. We've got the center footing here, and that third suction point is right on the other side of the wall. Front of the house is there, and the garage is here. So what I've done here is core a hole through the floor. I dug a suction point here so that we could reach the front corner of the house, and then I augered under the footing to tie into that other suction point that I have on the other side of the wall here. And then I've put a styrofoam plug in here that would support my concrete, so I re-poured the concrete here. The other alternative to stitching under the footing would be to simply run a pipe through the wall and create a suction point there. I personally think that looks tacky. I wouldn't do it in my own house, so I don't like doing it in my customers' houses. When we put the carpet back here, you're not going to see any of this. So that's why I opted for that. So let's go ahead and take a look out at the radon. So our radon fan is in the garage of this house. So we came out of that mechanical room here. We've got our fire stop collar on that goes around the pipe. It protects the house from a garage fire. One of the things that's required by code. We've got insulation on our pipe. It doesn't just make it pretty, it protects the system from freeze up, and it stops condensation from forming on the pipe and dripping on sheetrock and stuff like that. Way up there we've got our radon fan that's creating the suction, and then it exhausts out through the house there. So the fan that we have there, it's really cool. They have these EC fans now. So it's got a potentiometer in there, and we're able to dial that fan in to exactly the setting we need. So on this one, we didn't need 100% power. We're at about 60%. So it makes the systems really efficient and really easy to dial in to what we need. So out here, we've got our exhaust point up on the roof there. So we've got a Curtiguard cap on top that prevents debris from that tree falling in there, squirrels, acorns, stuff like that. And then we paint it to match the shingles. So it looks a little bit nicer, blends in, and then that the dark color is going to help the sun keep it a little bit warmer, less likely to freeze. And we also use 4-inch whenever we're outside as well, 4-inch pipe, to help prevent those freezes. So we're back in the mechanical room here, and just a few things before we wrap up. Just talking about the importance of the diagnostic testing. That's really the only way to know that the system you install is going to work. So to dial everything in, going back to our micromanometers, we want to get 3 pascals of negative pressure in our furthest weakest test hole under max depressurization. We've kind of talked about that in some of the other videos. But with that fan and with the valve on our second suction point there, it allows us to fine tune everything and make a really energy efficient and effective radon system. So this system, if I had that fan cranked up to 10, moving 80 CFM, would have cost $389 a year to operate. We're able to get it down to $75 a year. The fan is only 35 watts, and it really cuts down on the noise. So to dial everything in, you can see there's a little bit of science that goes into this, and this is the part that I nerd out on. But all these numbers are negative unless I have a plus sign on them. So you'll see a few plus signs scattered throughout there. But that operating cost and the energy efficiency is something that I think is really important, because this radon system, it saved them $314 a year by me spending a little bit more time digging deep and dialing everything in. So over 10 years, that's over $3,000 of savings right there. We've got an audible alarm, which is also now a requirement, and we've got our visual manometer, also referred to as a U-tube. To wrap up, I'm going to restretch the carpet where I've got the test holes. I'll clean up, and I'll do my backdraft test on the natural draft water heater. If you'd like to see more on that, we've covered it in some of our other videos. I'm Jesse with American Radon. Thanks for watching.